Okay, now in the last video I said that if I have a function y equals x to the power n, where n is some constant, then dy over dx is equal to n times x to the power n minus 1. So we'll use this and just do a few, see how we can differentiate a few functions. So let's say if I'm given y equals x to the power, let's say 8, then dy over dx will be equal to 8 times x to the power 8 minus 1. So n is equal to 8 in this case. So I just bring that power to the front, bring the 8 to the front, and then reduce the power by 1. So this gives 8x to the power 7. Similarly, if I have, let's say, y equals x to the power 14, then dy over dx is equal to 14 times x to the power 14 minus 1. And in this case, I get 14 times x to the power 13. And you can probably imagine that differentiating something like this is quite a trivial case. Perhaps some care must be taken though when you're differentiating functions with negative or fractional powers. So let's say if I have x to the power minus 5. So in this case, dy over dx would be equal to, bring the power to the front, so that's minus 5. I have minus 5 x to the power, and make sure you do not make the mistake of writing this as x to the power minus 4, because we are reducing the power. So that's minus 5 minus 1. So this becomes minus 5x to the power minus 6. Okay, I'll also take one with a negative fraction. So let's say if I have y equals x to the power minus 4 over 3, then dy over dx would be equal to minus 4 over 3 times x to the power minus 4 over 3 minus 1, and that gives minus 4 over 3 times x to the power minus 4 over 3 minus 1. So that's minus 4 over 3 minus 3 over 3. So this gives minus 7 over 3. Okay, now if I have some constant multiplying the function that I want to differentiate. So for instance, let's say if I have y equals 6x cubed. If I have a constant multiplying this polynomial, then I can just take the constant out, take the 6 out, and then differentiate 3x cubed. So that gives 3x squared, and this is equal to 6 times 3 is 18, so I get 18x squared. And very often you don't have to write the 6 and then write 3x squared. You can just take this as 3 times 6, which gives 18 times x squared. So if I take another example, let's say if I have 4x to the power 5, and I want to differentiate this, then dy over dx will be equal to 5 times 4, that's bringing the 5 to the front and multiplying it with the 4. I get 20 x to the power 5 minus 1, that is 20x to the power 4. And let's take a few with fractions and negative numbers. So let's say we have y equals minus 2 over 3 times x to the power 4 over 5. In this case, dy over dx would be equal to, I have minus 2 over 3, and then differentiating this function, I have 4 over 5 times x to the power 4 over 5 minus 1. So that's 4 over 5 minus 5 over 5, because 5 over 5 is equal to 1. So this gives minus 2 times 4, this is minus 8 over 15 times x to the power minus 1 over 5. Okay, let's take something very slightly different now. What if we have, say, y equals x cubed plus 2x squared plus 3x? Now in this case, dy over dx will be equal to, now when we have additions or subtractions of smaller functions, I can differentiate each of these parts separately and then add them together. So the derivative of x cubed is 3 times x squared. The derivative of 2x squared is equal to 4 times x, and the derivative of 3x is equal to 3. So when I have a sum of certain functions, I can differentiate each part separately and then add them together. And if you're wondering how did 3x become 3, you can think of the 3x as 3x to the power 0. So this is the same as, 3x as 3x to the power 1. And differentiating x to the power 1, I get 1 times x to the power 1 minus 1, which is 0. And x to the power 0 is equal to 1, so I just get the term 3. Okay, let's try couple more examples. So let's say we have y equals 4x to the power 4 minus 2x to the power 2/3 plus, let's say, 2/3 of x cubed minus 4. Okay, now dy over dx in this case, so differentiating each of these, all I have is pluses and minuses in between these individual functions, so I differentiate them one by one. So differentiating 4x to the power 4, bring this 4 to the front, so that would give 4 times 4, that gives 16x to the power 3, minus 2 times 2 over 3, so that's 2 times 2 over 3, times x to the power minus 1/3, because that's 2/3 minus 1. Then I have plus 2 over 3 times 3x squared plus a 0, because when I differentiate a constant, I get 0. So I can simplify this to get 16x cubed minus 4 over 3x to the power minus 1/3 plus 2x squared.